Hi, hello, good morning, good afternoon, good evening, whatever time you might be watching this. I would like to welcome you all back to this academic year, and it's still the great teacher Alcantara here back with an updated version of the lessons for Mathematics 8. For this very first episode back, we're going to discuss factoring by GCF or GCMF. With that out of the way, let's proceed to the lesson for this video. Now let's start with factoring by GCMF or GCF. Basically, factoring is the inverse process of multiplication. For example, you have 1 times 2. The product of that is 2. Factoring works the other way. In order for you to get 2, you can have factors such as 1 times 2. So for example, we have the following numbers. We have 24, 36, and 60. We can actually apply factoring here in different methods or different ways. Some of them you might be familiar with already, and that's why it's important for us to have a refresher so that you will be able to know which one suits you best. So for example, for 24, we can try a long method for this one. We can call it the long method. Basically, for the long method is that we try to think of different factors for 24. Let's say that the first set of factors that I have for 24 are 12 and 2. That could be the possible factors of 24. The thing here that we're doing, just to give it a context, is that we want to put these numbers in their prime factors. So since 12 is not yet prime, we can still find factors for 12, and we can have 6 times 2 for 12, and let's just bring down the first 2, and still 6 is not a prime number, so let's continue. 6, that can be 3 times 2, so just copy the other 2's from above, and in this case we have now written it in its prime factors. So for 24, it's equal to 3 times 2, which is 6 times 2, that will be 12, and then times 2, that will be 24. Just to give some people who might be confused, sir, why are you using a dot for multiplication instead of x? Because now that we are discussing polynomials, the x might be confused with a variable. So it's important for us to make use of different symbols for multiplication. For multiplying, we can make use of a dot or parentheses. So to showcase this, let's try to use that in our other examples later on. Okay. So for 36, instead of doing the long method, what I'm going to show you is continuous division. So let's say that we have 36 and we wish to find the prime factors of this given. All we have to do is to have 36. You might have seen this before. So we will think of different prime factors that will serve as divisors for this number. Let's say that we have 3. So 36 divided by 3, that will be 12. And 12, that can also be divided by 3. So 12 will now become 4. And 4, that is also divisible by 2. So have 2. 4 divided by 2 is 2. So now that all of them are prime factors outside of this image right here, we can say that 36 is equal to 3 times 3 times 2 times 2. So 3 times 3 is 9, times 2, that is 18, times 2, that is 36. You can also show it this way if you wish to use parentheses. Have 3 times 3 times 2 times 2. Grouping symbols such as parentheses and brackets are used in algebra as you move forward in order to imply multiplication or the distributive property. Next, for 60, we can have here what some of you might call as the factor tree, wherein you will have 2 branches for 2 sets of factors, or for a set of factors for 2 factors. Yeah, that's the correct term for that. So we can have here, for example, 5 times 6. 5 times 12, I'm sorry. 5 times 12. So 12 here can also be factored as 3 times 4. This 4 right here can be factored also as 2 times 2. So we can say that 60 is equal to 5 times 3, which is 15, times 2, that is 30, times 2, that is 60. So we can do it this way also. So in here, what we've shown you already is that we can have the long method, the continuous division, and we can also have the factor 3. These are different ways of getting the factors of different numbers. And at the same time, I would like to say this, that if you're already good with doing this, if you're already good with doing this mentally, you don't have to write it this way anymore to save time. The reason why I would like to show different ways of getting it is to prove again that in mathematics, there are different ways of solving a given problem. Okay, just like in life. So now, what if we have finding the factors of algebraic expressions? In this case, we're focusing first on monomials because that is our lesson for today. Monomials class, I'll write it here. Monomials, from the name itself, mono means one. Nomials actually means terms. In this case, we now have monomials. It's also important for you guys to take note of this because there are different kinds of polynomials from your previous lessons. You have to remember that. For you to factor out the given in this slide right here, it is important for you to remember a certain law in the laws of exponents. And we call that as the product law. So let's say that we have here a raised to 4. Just to show you how to get this in order for you to remember how it works. Let's say that we have the product law, which is a raised to 3, let's say. And we would like to multiply this to a raised to 2. So in order for you to get the product, when you multiply these two right here, you simply add the exponents. This only works if your base is the same. So copy the base, add the exponents, you'll get a raised to 5. The reason why we're recalling the product law here, so that you'll be able to figure out different factors for a raised to 4. So since the idea in the product law is that we add the exponents when they have the same base, factoring a raised to 4 is as easy as doing this. A raised to 4 can be the product of a raised to 2 times a raised to 2. Because again, they have the same base, copy the base, and then add the exponents. 2 plus 2, that is 4. So you can also have here, a raised to 4 can also be equal to a raised to 3 times a. Again, class, if there is no exponent indicated, it's automatic that that certain variable is raised to the power of 1. So that's the case here. So you might be asking, sir, is it possible to have a raised to 4? I'm so sorry. A raised to 4 times a raised to 0. Yes, because 4 plus 0, that will be equal to 1. Now, that will be equal to 4. Now, you might be wondering, what is a raised to 0? A raised to 0 is the same as 1. That's why I mentioned 1. And again, this is one of the laws of exponents, that any term raised to the power of 0 is equal to 1. Okay? So you may have this also as a raised to 4 times 1. That can also be the factors for a raised to 4. Same case with the others, it can be similar to that. D raised to 7 can be equal to d raised to 4 times d raised to 3. Same base, add the exponents. Now, I would like for us to focus on b raised to 4 and c squared. This can be factored out in different ways. It can be simply factored as b raised to 4 times c squared. Because again, they don't have the same base. So that's the case when you're multiplying terms or variables. When they don't have the same base, all you have to do is to put them together. Like for example, let's have a times b. Since they have different bases, all you have to do is to put them next to each other. It's a, b. This is actually one of the ways to also indicate multiplication. Like for example, you have 3b. This can also be written as 3 times b. That's why when we do evaluating of variables, when we have a given value, we multiply the numerical coefficient and the variable next to it. So always remember that. So we can have this also as b raised to 2 times b raised to 2 times c squared. There are different ways of doing it, and it's a little long, so I just have to pause it right here. So that is a recall of how to factor out monomials and how to factor out real numbers. In this case, we now have to move to identify what the GCF is. And the GCF is basically the greatest common factor. Let's put it that way to make this one quick. Now, in relation to the GCF, we can have 24 and 36, 24 and 60, 36 and 60. So in this case, I would like to also focus on one example only so that it will be quick for all of us. At the same time, it is important that you can apply different ways in here. You may do this mentally if you're familiar or you are a master of the multiplication table. You can do this mentally. But if you need guidance, you may do the long method, you may do the continuous division, and you may also do the factor tree. So in this case, I would like to do the long method for each. So I'll focus on example number 1, which is 24 and 36. Let's say that we have 24. The factors of this can be 12 times 2. Also 6 times 2 times 2. Can also be 3 times 2 times 2 times 2. Now, for 36, we can have the following. We can have 12 times 3. This can be also written as 6 times 2 times 3. This can also be 3 times 2 times 2 times 3. So let's just fix how it's written. You can have 3 times 3 times 2 times 2. Just to indicate or just to put it in descending order. So in this case, to get the GCF, you can line them up or put them in rows. So let's say 36 again is 3 times 3 times 2 times 2. And we have 24 as 3 times 2 times 2 times 2. So what we did here is we put them in rows and columns in order for us to identify what they have in common, since that's the idea of GCF. So therefore, you can say that they have 3. So let's bring it down. They have 2. Bring it down. They have 2 here, so we bring it down. So therefore, the GCF of the following is 3 times 2. This is 6 times 2. That's 12. That is our GCF. And actually, if you are good with this, you can actually see it already in the beginning. If you start with just simply dividing it by prime factors, it can help you out. So there are different ways again of doing this. So just choose where you're particular with. This one is a bit long, but it's good to use for those who are beginners because this helps you out in giving an answer that is exact because you do it step by step. Okay? There's no problem with that. We're doing things one step at a time. Now, in this case, if we wish to find the GCF of monomials, this one you don't need to do any of the methods that I taught you because there is a technique in order to identify the GCF in terms of monomials. First is, do they have the same base? Next is, what is the lowest exponent? And that, ladies and gentlemen, is our GCF. So for example number 1, you have a raised to 4 and a raised to 7. They have the same base here. So the GCF for number 1 is a raised to the lowest exponent, which is 4. So the GCF is a raised to 4. The proof here, so that later on I will no longer show it, a raised to 4 can be factored as a raised to 4 times 1, while a raised to 7 can be factored as a raised to 4 times a raised to 3. And from here on out, you can already see that they both have a raised to 4 in common. So that is their GCF. If you follow this for item number 2, don't be in panic mode if there are 2 or 3 different variables here. Again, just follow. Look for similarities. Since they both have the variable b, let's start with that. The lowest exponent is 3. So therefore, b raised to 3. And then let's go with the C, since they both have it. The lowest exponent is 2. So therefore, the GCF is b raised to 3 c squared. So number 3 also works the same as the first example. This is d raised to 4. So do not panic with these examples. It's just how the way it goes. Take it one step at a time and remember the techniques that I'm teaching you so that you will not have a problem with it. Now, we are going to factoring by GCMF or factoring by GCF. So let's start with our very first example. Our very first example is 2x plus 4. And here, since we're still starting, there are a few guide questions that I would like you to think about while we're answering it together. So the first one here is how many terms that are given in the polynomial and what do we call such polynomial? Class, in order for us to identify the number of terms, the terms are separated by two operations. It can either be addition and subtraction. Either addition or subtraction. Those two helps us identify number of terms. This doesn't work because if it's multiplication, it doesn't work that way. Like 2x, there's multiplication in there, but we don't count it. They are still together. Again, we can only identify number of terms with the help of either addition or subtraction. So therefore, in this case, 2x and 4 are separated by that addition symbol, giving us 1, 2 terms. Since there are two terms, we call this as a binomial. Bi means two, nomial means terms. So there are two terms in this given. So for the next guide question, observe the terms in the given polynomial. Do they have something in common? If yes, what would that be? So we can say that 2 and 4 has something in common. And what common are we talking about here? We're talking about that 2 and 4 actually has a GCF. And the GCF of 2 and 4 is actually 2. So how do we factor it out? How do we do factoring by GCF or GCMF? So let's copy our given 2x plus 4. And since we have identified the GCF already, so let's put 2, the GCF, outside a grouping symbol. So what are the things or terms that we're supposed to put here? So what we're going to do here, class, is we're going to divide the terms here, each of them, by the GCF. And the GCF is 2. So 2 divided by 2, that will give us 1. So this will be 1. And x remaining, so 1x, that will be x. Positive 4 divided by 2, that's positive 2. And here, we have already done factoring by GCF or GCMF. And that's it. This is the answer. 2 times the quantity x plus 2. So in what way can we prove that our answer is correct? By doing multiplication or distributive property. So to check if our answer is correct, this one, so for checking, all we have to do is distribute 2 to the given inside the parentheses. So 2 times x, that is 2x. 2 times positive 2, that's positive 4. And as you can see right here, we went back to where we started. Therefore, this proves that our factors or its factored form is correct. So that is for our first example. Going to the second one, you can see here that, again, we have terms here separated by addition symbols. In this case, you have 1, 2, 3 terms. And since we have 3 terms, this makes it a trinomial. Now, this is something that I want you guys to not also panic with. The first thing that you need to do here is to look at the numerical coefficients and constants if they are there. And then next, you may check out the variables. As you can see, there are no other integers that are numerical coefficients or constants in the given. Like it's just 3 here. So therefore, there's no partners for 3. They don't have that in common. But in terms of the variable, we can see that they both have x and y. You can see that they both have x and they both have y. So what I would like you guys to check in this one is to remember the technique that I taught you with the review. Is that the one with the lowest exponent will be the GCF. So for x, you have 2 as the exponent here. Here it's none. Here's none. It's not written. So therefore, it's 1. So that makes our GCF for this example for x as x. And for y, you can see it's similar to that situation, that y is also our GCF. So it's xy. Again, the reason why it's y, because the lowest exponent is 1. In this case, we will do what we did earlier. We will divide each term by the GCF. So the GCF here again is xy. Here it's xy. Here it's also xy. Now, one of the things that I would like you all to remember is the concept of the quotient law. Now, why are we discussing the quotient law in the middle of a solution? Because I would like to make sure that all of you know how to divide monomials or variables in this case. For example, you have x squared divided by x. As you can see here, class, they both have the same base. So you just copy it. And what do you do when you're dividing? If it's multiplication, you add. If it's division, you subtract. So 2 minus 1, so that makes it x raised to 1, or simply x. So that's the case here. So continuing with our solution, this will be x. Now, sir, paano yun? Y divided by y. They are both raised to 1. So therefore, this will be y raised to 0 or 1. As simple as that. And since that's the case for the first term, 1 times x, that is simply x. So no need to write it. There's another way of doing this. You can simply do cancellation. Since they both are the same, so just cancel out y, cancel out y. Again, that's a technique. That's not the mathematical term of doing it, but it's a technique that you can apply, because again, you don't have to write it anymore when it's 1, when it's next to different terms. But if it's the only thing remaining, it should be 1. And that will be the case for one term in this given. Since there is nothing to be divided with 3, so just copy it. Same case with earlier, x and x, that will give us 1. And for this is 2, y squared and y. Same case again with the example. We can have here as 3y. And this is the one thing that I'm mentioning earlier. Since this is xy divided by xy, xy is being divided by itself, this is automatically equal to 1. So no need to overcomplicate things. So this is our final answer for this given. xy times the quantity x plus 3y plus 1. So that is our final answer for this example. Now, it's a combination of the two things that we have discussed today. Getting the factors of polynomials based on the numerical coefficients and the integers. And the second example, we focused on the variables. Now, it's going to be a combination of it. Now, from the guide questions, we now have a step-by-step guide here. So let's focus first on getting the GCF of the numerical coefficients. So we have here 14 and 21. And the GCF of that is 7. That's for 14 and 21. In terms of the variables, you can see here that they have x for both terms. And again, the technique is that the lowest exponent will be the GCF. So this will be x. Now, to get the GCF or the GCF for this example, simply multiply the GCF of the numerical to the GCF of the variables. So the GCF that we're going to use for this example is 7x. And lastly, we divide each term by our GCF. So 14x cubed plus 21x, we divide them both by our 7x, our GCF. So the factored form of this given example is as follows. 14 divided by 7, that is 2. X cubed divided by x, 3 minus 1, that is 2, so x squared. Plus 21 divided by 7, that is 3. X divided by x, that is 1. No need to write it anymore because 3 times 1 is 3. So this is our final answer. If you wish to check it, 7 times 2, that is 14. X times x squared, that is x cubed. 7x times 3, that's 21x. So it's correct. That's how we do it. Continuing, we can go with our last example for factoring by GCF or GCMF. We have 4x minus 6xy minus 8xz. Same case, let's start with getting the GCF of our numbers here for numerical coefficients for -6, -8. The GCF for this one is 2. And in terms of the variables, they all have x. So therefore, the GCF that we're going to use is 2x. So we have 4x minus 6xy minus 8xz. We have to divide them all by 2x. And now our factored form will be 4 divided by 2, that is 2. X divided by x, that is 1, so we can cancel that out. -6 divided by 2, that's -3. X divided by x, 1. Then y, we just bring it down. -8 divided by 2, that's -4. X divided by x, that is 1, then z. So here is our final answer. Class, do not forget when dividing, especially polynomials and each terms with the steps, do not forget if they are positive or negative. Okay? So we have here 4x divided by 2x, it's positive, so positive 2. -6xy divided by 2x, that is -3y. Same case with -8xz divided by 2x, that will be -4z. And that is our final answer. If you wish to do checking, 2x times 2, 4x, 2x times -3y, that is -6xy, 2x times -4z, that will be -8xz. So we have here the correct answer. And that ends our discussion. Do not forget to ask questions or for clarifications, you can leave them in the chat. Do not worry, all these lessons are here and I will try my best to post regularly in order for you all to have a guided learning outside of our classes. Same case for those who will stumble upon this. Hopefully you all get to learn something new and get to have some tricks that will help you out and easing your way with your grade 8 mathematics life. And in that case, in case you guys don't hear me or see me, well, good morning, good afternoon, good evening, and good night. Bye bye. Peace out.